Well, I guess this is part two of the prop shaft speed sensor video. I'm going to do two things here. First thing is I'm going to recapture those waveforms because I wasn't very happy with them. I think that I must have had a bad connection with the last video, and so even though the problem is now solved, I'm going to go back and recapture the videos for the rear prop shaft. And then the second thing is I'm going to take apart that bad sensor and we'll have a look at it. Let's get started. Anyway, the last time I did this, I wasn't thinking I should have used the scanner to verify that I had good connections with my breakout leads. Keep an eye on this. I'm in drive on the jack stands, and I'm going to start the vehicle, and we're going about 10 kilometers an hour now, and you can see my rear prop shaft speed is plenty strong. And interestingly, the front prop shaft is fine as well, even though the front wheels are on the ground and not moving, amplifying the fact that this particular transfer case allows a passive slip of that front shaft. So that's what we expected. We're on a plus or minus 5 volt scale. We've got an AC wave, which is increasing both in frequency and amplitude as the vehicle speed increases. This signal is sent to the transfer case module and then converted to a digital signal, and then that communicates with other modules in the PCM. Interestingly, it's centered around the 0 scale. There's no evidence of a bias voltage here. I love wrecking things even more than I like fixing them. Let's take this thing apart and see what's inside. I didn't cut all the way through it, so that's just the end of it. This end's not magnetic. It looks like the plastic is molded all around this, so I'm not sure how far this is going to go. But okay. I split it on both sides. There we are. So there's the coil, the magnet's here, and the coil is here. I got you looking through the magnifier right now. Here's the wires in the coil. You can see how fine they are. I broke those with the hacksaw when I was taking it apart, but there's little doubt in my mind that the reason this coil suddenly had high resistance is that one of these wires melted. The insulation around it melted against the other, and it caused an open. And when the teeth of the tone ring come zooming by this changes the reluctance of the magnetic field, which in turn causes the electrons in the coil to zoom back and forth in an AC pattern, creating the analog signal. And then here we'll take the magnet right out. That's the magnet there. So that's it. These systems are elegantly simple and surprisingly durable. Thanks for watching.